Hello, I'm Satvik. Today we are going to build a machine learning system that can predict whether a person is diabetic or not. To build this model, we are using one of the important supervised learning model, that is a support vector machine model. In this support vector machine model, as we train the machine learning model with the data, this support vector machine model, after training the data, it identifies a hyperplane and divide it into positive hyperplane and negative hyperplane. As the moment when you induct a new instance data, then it identifies the new instance data as either of a hyperplane, negative hyperplane or positive hyperplane, and then it gives the predicted outcome. Now, this is about the support vector machine model. Let's understand the code now. In the first step, we will import all the dependencies. Here we imported the standardization, we imported test train split, we imported SVM, support vector machine model, and also we imported the accuracy score. After the importing, then we will collect the dataset and then analyze the dataset by printing the first 5 rows of it. Here this is all the data, the glucose, blood pressure, insulin, BMI, and these are the outcomes, and the outcomes are labeled by 10, 101, so on like that. Now, to be more precisely, we will get the shape of our data. Like we have the 768 rows and 9 columns, and then after getting the shape of the data set, and then we will print the statistical measures of our data. By these statistical measures, we will get the mean, standard deviation, percentage, minimum and maximum between percentages of our data. And after that, we will divide the labels. We will identify how many zero labels are there and how many one labels are there. By printing those labels, we will have 500 zero labels and 268 one labels. That indicates zero are non-diabetic patients and one is a diabetic patient. So then we will take the mean of all zeros and ones in the data set. Here we print the mean of the zeros and ones in our data set. The mean count of glucose for a non-diabetic person is 109.98, and the mean count of glucose for a diabetic person is 141.25. In the same way, it goes on with the BP, skin thickness, BMI, and age also. We will get all the means of all the columns, and then we will separate our data. We will separate our data and the labels. As I told you, we will separate this whole data and these labels by assigning X as the diabetic dataset and Y as the dataset outcome, and we'll print those X and Y. Now, as we imported the standardization function, we will execute our data and make our standardized data. After data standardization, we will print the standardization data, and then we will assign X as the standardized data and Y to be the possible outcome. And we will print both X and Y's. After printing and standardizing our data, now we will test and train our data. For that, we need to split our data into test data and train data. Here, we will assign X train, X test, Y train, and Y test, and then we will assign the test size of 20% of our whole data. You can see here the test size I have given is 0.2. That indicates that 20% of our whole data is for test and 80% of our data is for training the model. So to be more precisely, here is total number of rows and columns. In train, we have given 614 rows and 8 columns. For test, we have given 154 rows and 8 columns. After assigning the test and train split, now we will train our model. As we imported the SVM function, now we will train the model. We will train our support vector machine model by using these assigned xtrain and xtest, ytrain and ytest variables. Now, after training our support vector classifier, we will try to print the accuracy score. We will try to get the accuracy score of our training data and the test data using the imported accuracy score library. Now here we are importing the accuracy score of our training data using the classifier predict. We use the support vector machine classifier. The accuracy score of our training data is 78.66, approximately 79%. And the accuracy score of our test data with the classifier predict is 77.27 percentage, or approximately it is 77.5 percentage or 78 percentage. Now, after getting the accuracy score, after making our data standardization and getting the accuracy score, now we need to input the data. We need to make a predictive system. This is that input data. Now here we need to change the input data into a numpy array because we induced the array there. So we need to change the input data to a numpy array, and then we need to reshape our array, because as you induce the input data, it takes for the whole 786 rows, but what we need is for only one instance. So we need to predict for only one instance. Then we need to reshape our array for 1 comma minus 1, and then we need to standardize that input data also. After standardizing that, now we can predict our prediction by the classifier.predict, and then if the prediction is equal to 0, then the person is not diabetic. Else if not equal to 0, then obviously the person is diabetic. So for that, we'll give here our input data. For that, we will go to our data set. So this is the data set. So I open my data set using notebook so that it will be easy for me to take the data from here. So this is our data. Now here I'm choosing this data set. Let us see how this system will predict this data set. As you can see here, this dataset belongs to a diabetic person. This one label indicates this dataset, this whole labels are belonging to a diabetic person. Let us see, we'll print here. As you can see here, the person is diabetic. The person is diabetic, so it's working. Let us see for another instance. Let us take a instance of non-diabetic person's data. So here I have a non-diabetic person data. Let us see. We'll place it here. Try to execute it. Here you can see the person is not a diabetic. Here I induced the data of a non-diabetic person, so it is giving that the person is not a diabetic. Previously we induced the data of a diabetic person, then it showed the person is a diabetic. So this is the full working model of prediction, and I also placed my GitHub link of this repository and also the data sets. Thank you.